Good day, everyone. You are welcome to Gala Science Academy. Our today's topic in organic chemistry is classification of organic compounds. So, if I talk about the word classification of organic compounds, is a method of classifying all organic compounds into different classes based on the feature they have in what's in common, or based on some characteristics they have in what's in common. And the organic compound can be broadly classified into two parts. We have what we call what? Aliphatic compound, and then we also have what we call what? Cyclic what? Compound. So the other classification, organic what? Under this classification, we have organic what? Organic compounds can be classified into two parts. The first one we have what we call what? Ali what? We have what we call aliphatic. Aliphatic compound. And the second one, we have what we call cyclic what? Compound. If we are talking about what? Aliphatic compound is an open chain compound. You can also call it what? Open what? Open chain compound. But if you are talking about cyclic, the cyclic compound is a compound that is called what? A closed chain compound. That is, in this aliphatic, the structure is in what is in open chain. In this cyclic, the structure is in what? In a closed chain. And this aliphatic hydrocarbon is divided into two parts. Under aliphatic hydrocarbon, we have what we call aliphatic, and we also have what we call what? Aromatic. No, we have what we call what? Saturated compounds. And here we have what we call what? Unsaturated compound. What is the saturated compound? The organic compound we have here, they exist in form of what? A carbon-carbon single bond. Exists in form of what? A carbon-carbon what? Single bond. An example for this compound here, we have what we call what? Alkane. An unsaturated hydrocarbon is a compound that is comprised of two things here. We have two what? Two things here. This unsaturated hydrocarbon group into the what? Or unsaturated compound into two. We have what we call alkene. Alkene. Where here we have what we call what? Alkane. And at this side we have what we call what? Alkyne. See, this unsaturated is an hydrocarbon that is have carbon double bond or carbon triple bond. So here now is a kind of compound that have carbon double bond belong to the what? A what? Alkene. A compound that is have carbon triple bond is belong to the what? A what? Alkyne. Sorry. But this one, saturated, is alkane. What is this functional group? Carbon what? Single bond. And both this saturated and unsaturated organic compound here, they can exist in what? In two stage. In what one? This saturated, you can have it in what? In open chain. So you can have it in what? In straight what? Straight chain. Or you can also have it in what? In a branch chain. Likewise for the alkene and alkyne. Likewise for what? Alkene and what? And alkyne. In short, this aliphatic can exist in two forms: straight chain and what? Branch chain. And they are also called open chain what? Compound. What is the what? The straight chain. This compound now, let me take this as a case of study for the straight chain. If I have what? A compound that have CH3, CH3, CH2, CH2, CH3. See, look at this compound now. It contains how many carbon atoms? 4. The 4 carbon atom it contains here is the one is in a straight chain. Straight what? Straight chain. And the name of this compound, you can call it what? What? Butane. You call it what? Butane. Because it contains 4 carbon. And the functional group here is carbon single bond. But this compound can also be in what? In a branch chain of what? Of this one. This one can be in the branch chain. Let's check it. This is the example of what? Of this. The branch chain is to be what? C what? If you have CH3, CH, CH3, and CH3. Let's check this compound. How many carbon do we have here? 1, 2, 3, 4. How many hydrogen? 3 plus 2, 5. 7 plus 3 making 10. Here, how many carbon? 1, 2, 3, 4. How many hydrogen here? 3 plus 1, 4 plus 3, 7 plus 3. You can see that these two compounds, they have the same carbon atom and the same hydrogen atom. So this structure is a branch of this structure. So if this one is butane, this one, we call it what? 2-methyl what? Propane. Forget about the nomenclature. We will soon get there. So this one can also call it what? Isobutane. This 2-methyl propane. So this 2-methyl propane is a branch structure of what? Of normal butane. So once again, the aliphatic organic compound is a compound that is occur in open chain. The open chain may be what? A straight chain or maybe what? Branch. And it's very common in what? In saturated hydrocarbon and unsaturated what? Hydrocarbon and some organic what? Compound that can exist in a straight chain or in what? In a branch chain. Look at this too. If I want to use this the same butane here for this compound that have double bonds, we can also have what? CH3, CH2, C double bond, CH double bond, CH2, CH what? 2. 1, 2, 3, 4. It is butane, abi? Instead of calling it butane, we have double bond air. The double bond means what? E-N-E. You call it what? Butane. Abi? So this butane can also occur in a what? In a branch form. Let's check it. CH3, CH, CH3 here, double bond, CH2. Look at this structure. This second structure is related with this first one. Can the number of hydrogen and the number of what of carbon atom is the same? The double bond is here. So this one you can call it what? 2-methyl propane. So this structure here, now you call it what? What's be the name? 2-methyl for what? Propane. I said, if you don't understand the nomenclature, be calm. You will get there. So I'm just trying to tell you that what the aliphatic hydrocarbon is an open chain compound which exists in two forms, either in what? In a straight chain or in a branch chain. And the common example is saturated hydrocarbon and unsaturated what? Hydrocarbon. That's for the what? Aliphatic. Likewise, we have in what? In alkyne. So the next one is what? Cyclic. The word cyclic means what? Closed chain. That is, any organic compound that is exists in a closed chain or in a ring form. The two ends will close together. That's what? Cyclic. If the two ends is what is in open or in a straight line or in a branch, we call it what? Aliphatic. So under this cyclic hydrocarbon is divided into what? Into two parts. These are the class of what? Of cyclic hydrocarbon. The alpha we call what? The alpha we call homocyclic cyclic compound, and we also have what we call what? Heterocyclic what? Compound. What is in this homocyclic compound? The two of them, they are in what? In ring chain, in ring form. They exist in what? In ring form. The word cyclic means what? Exists in what? In ring form, which is what? Closed. That's the meaning of what? Cyclic. And if the cyclic compound is contain carbon to carbon bonds throughout, carbon to carbon bond throughout without any other element, you call it what? Homo. You know this homo means what? Same. So this homocyclic is an organic compound that contain carbon to carbon throughout. Where this hetero means what? Different. In hetero is a compound that contain carbon to carbon compound and other elements. And other what? Elements. If if you are talking about what this heterocyclic, example of this heterocyclic, we have what we call what? We have what we call furan. Look at furan. Furan is an organic compound that contain is a cyclic what? Compound that contain carbon to carbon and other. This is what furan, double bond there, and we have it in this form. So on top here we have what? Oxygen. This is what furan is a good example of what? Of heterocyclic. But in case of homocyclic, there won't be what? Oxygen here. It will also have what? Carbon here. Because this angle here, this angle here, this angle here, this angle here contain carbon. And another example of heterocyclic hydrocarbon, you can also have what? Pyro. If you have pyro, this is also a structure. Instead of having what? Oxygen there, his own is what? We have nitrogen. We have what? Nitrogen here and hydrogen. So this is a pyro. The presence of this nitrogen here make this cyclic compound to be what? Heterocyclic. And let me put one more example there. And we can also have what? All these are double bonds. Let me put one single bond compound. We also have oxyran. Is also good example of what? Of good example of what? Heterocyclic. So any cyclic compound that contain other elements not from carbon is called hetero what? Cyclic. We also have pyridine. But in case of homocyclic, the homocyclic divided into two parts. We have what we call what? Alicyclic. We have ali what? Cyclic. And we also have what we call what? Aro what? Aromatic. What is aliphatic? So this aliphatic compound is an aromatic compound that contain carbon to carbon single bond or the carbon to carbon single bond throughout or carbon to carbon single bond carbon to carbon single bond throughout. Now, for example, you can have what? Example for this one, you can have this structure 1, 2, 3. You call it what? Cyclopropane. You call it what? Cyclopropane is a cyclic compound. In case of we have what? Is a cyclic compound. This it has how many angle? 4. You call it what? Cyclo what? Butane. Are we? And if you look at this one too, this structure, you can see that what this structure, you call it what? How many side? 1, 2, 3, 4, 5. Cyclo what? Propane. And like this structure too, We have how many what structure here? How many shape? 1, 2, 3, 4, 5, 6. Are we? 6 is X. Cyclo, a what? Benzene. So all these compounds they are called what? Alicyclic. They have carbon-carbon bond throughout. But in case of aromatic organic compound, this one also contains carbon-carbon throughout in a closed chain or in a ring chain. The aromatic hydrocarbon contains what? Carbon-carbon throughout in a what? A closed chain or in a ring chain. But the unique feature of this aromatic hydrocarbon is what? The double bond and single bond, they alternate with each other. Here in aromatic, the what? Single bond or what? Alternate with what? Double bond. What is the meaning of that statement? That is, if you have a single bond here, in the next carbon we have what? Double bond. In the next carbon we have single bond. In the next carbon we have double what? Double bond. So what? This is single, double. But mind you, it will be what? In a open chain like this, must be in a what? In a closed chain. Because we are dealing with what? With cyclic. Call it aromatic cyclic. So for this man now, the common example here is benzene. Is what? Benzene. This is benzene. If this place is what? A single bond, here you have what? Double bond. This is single, here we have double. This is single, here we have double. And the example here is what? Is benzene. So this is what? The classification of organic what? Organic compound. So be calm. We are going to treat them one after the what? Other later in the future of the what? Organic what? Chemistry.